Hi, in today's video we're going to take a look at installing Davinci Resolve on Linux in a FreeBSD jail. Now, in a previous video I showed you how to install Davinci Resolve on FreeBSD using a chroot. What we're going to do is step it up a notch and install Davinci Resolve in an Ubuntu jail on FreeBSD. What I'll do now is switch across and show you how Davinci Resolve runs on FreeBSD, and then I'll come back and take you through the steps to set this up. Okay, let's open Davinci Resolve using our application launcher on FreeBSD. Here's the splash screen. I'll create a new project. Big Buck Bunny. Create a bin, import some footage, and drop it into the timeline. Okay. Press play. And fast forward a bit. So what we'll have a look at is the preferences up here, and if I come across to the memory and GPU, what you'll see is the Nvidia graphics card showing up and Cuda enabled. Okay, so let's just carry on with this. Let's just scrub through here and find a bit where he goes Bunny Rambo. Okay, so you can see that's all working, and I can click through the different tabs without any issue here. And this is Davinci Resolve running in a FreeBSD jail. In a previous video I showed you how to do the same thing using a chroot. And now the difference between the jail and the chroot is, in the chroot what we were doing is using an Xwayland window to display Davinci Resolve. And that had a couple of issues where sometimes the mouse would lose focus and you would have to toggle full screen back and forth to get the mouse to regain focus. We don't have that issue on the version installed in the jail, because what we're doing is, instead of using an Xwayland window, we're actually using the display on the host to display the window instead. So as I said, I can click through all these without any issue. We have the GPU set up and Cuda. I can scrub through this no problem. Come across to the cut tab. You can see the audio is working there. So what I'll do is I'll just come across and show you the export settings. So what I'll do is just create like a 30-second clip or something. Remove the excess footage. What I'm going to do is come to the deliver tab across here. So I'm going to give it a name, Big Buck Bunny. And what I'm going to do is actually go through the export options. So in the free version of Davinci Resolve, there is no support for H.264 video or AAC audio. On the paid version there is support for H.264 video but not AAC audio. You can import ProRes footage into Davinci Resolve, but as of Davinci Resolve 18.5, to export as ProRes footage you need a paid Davinci Resolve dongle. So the export options we have are quite limited. We have DNX HD, DNX HR, and uncompressed. Now, DNX HD only has specific resolutions that you can actually export to. So if you need a custom resolution, you're going to have to use the uncompressed export option, which will result in extremely large files. Okay, so we've got this set up. We're going to browse here, and what we're going to do is select this video directory here. And this is a directory that has been mounted from the host inside the jail, which allows us to import and export footage directly from the host instead of constantly copying files in and out of the jail. So I've got all that set up. I can just click add to render queue, render all, and it's going to start to render that clip. You can see this is just a 30-second clip, so it's going quite quickly. Okay, so that's now been rendered. So another thing to mention is dual displays. You can actually see we're getting the both displays listed. So I have two monitors. I have the laptop and an external monitor plugged in. With the version of Davinci Resolve installed in a CH root using an Xwayland window, we were limited to a single window. It is actually possible to set up dual displays, but what I found is it can be a bit finicky. Sometimes clicking between tabs kind of confuses it, and you can't find the window. So not quite sure why that's not working completely. Dual displays does show up, but I would recommend just sticking to a single display for the moment until I figure out what the issue is. So we do have everything working. The other nice thing about using Davinci Resolve in a jail as opposed to a CH root is with the Xwayland window, what would frequently happen is when you were clicking the tabs, the windows would kind of flicker, the drop-down menus would flicker and sometimes disappear. So for instance, when I click the preferences here, you can see this window's coming up behaving like a normal window. What would happen with the Xwayland window using the CH root is sometimes this window wouldn't display. You know, sometimes a window doesn't, it kind of flickers out and you kind of got to click back and then it will sort of reappear. So that was one of the issues with the Xwayland window, and I said we don't have that issue using a jail because we're using the native display on the host to actually display the window. So what's the difference between using a jail and a CH root for Davinci Resolve, and what benefits does it offer? Okay, so let's go through this. We're going to set up Nvidia and Cuda. The audio is going to be routed from the jail to the host using a pulseaudio socket. We're going to mount the video directory from the host inside the jail, and we're going to open Davinci Resolve using a desktop entry using our application launcher. A couple of other differences: we're going to be storing the jail in a ZFS dataset. We're going to be using an Xwayland rootless window instead of a rootful window. A rootful window is where Xwayland will open a big black window and then the application will be displayed inside of that window. A rootless window is basically like a native window. It will behave like a native application on the system, and it also resolves some issues using a rootful window where the mouse could lose focus. So let's go through some of the setups to get this working. So first of all, the system requirements. You're going to need 16 gig of RAM and a Nvidia GPU. Here's the instructions to clone the repository. There's a tree listing of all of the files included in the repository, so you can easily copy them into place. So the first thing we need to do is actually get the host set up for Nvidia and Cuda. So these are the packages that we want to install, and what we want to do is run nv-sgl run nvidia-smi. So if I come across to the terminal here, and paste that in, what you'll see here is Nvidia SMI driver version and the Cuda version. And we're going to need to keep a note of the driver version here, because we need to install the exact same driver in the jail as we have on the host to enable the GPU to work. So that's the first step. What we're going to need to do is actually install devbootstrap. We're going to be using devbootstrap to actually install Linux inside the jail. So that's the first step. Sudo pkg install devbootstrap. We're then going to install doas, which is an alternative to sudo. And what this is going to do is allow us to create rules that will allow us to run a particular command without entering a password. And this will be needed for the desktop entry we're going to set up. So we're going to install doas. What we have here in our user local etc doas.conf is this bit of code down here. We can see permit username, and what you need to do is change username to your username in all of these examples. And what we're going to be doing is adding a rule: permit no pass username command JEXEC. And what that allows us to do is execute a jail without having to enter our admin password. Okay, get some tea. So we've set up our doas conf. So let me just show you that here. User, hang on. User local etc doas.conf, and you can see down here I have the jail settings: permit no pass, my username, command JEXEC. So the next thing we're actually going to do is set up what are called devfs.rules, and this is located at etc devfs.rules on the Freebsd host. And what you can see here is we have this set of rules here. We have a name, Ubuntu jail equals 7, and then we have these set of rules. And what we're doing is we've got some standard ones here, which I'll just omit. Then what we're doing is we're adding the path to the mixer. So let me just switch across, and this should make more sense if I show you the actual dev directory. Okay, so you can see here this is the dev directory on FreeBSD, and what you'll notice is things like Nvidia CTL, Nvidia mixer. So what those do is these correspond to these items in here. So we've got the mixer and the DSP, which are for audio. We've got DRI, DRM, and Nvidia. And what these do is that these actually expose those items in the devfs directory on the FreeBSD host, and will allow us to add them to the jail's devfs directory. And this is needed so that the jail can actually access the GPU on the host. So what you need to do is edit your etc devfs.rules, put in this section, and then reboot. And the reason you need to reboot is because it needs to take effect. They need to be sort of mounted and ready for the next step we're going to do, because otherwise they won't actually show up. Okay, so what we're going to do, let's just have a little look at that. File devfs.rules, etc devfs.rules. What you'll see up here is I've got two sets. This is for mount points. This is so I can mount drives without entering my password. But this is the section we're interested in here, Ubuntu jail 7. And this is the section I just went over in the GitHub repository. Okay, so what we're going to need to do is actually set up our etc.rc.conf and enable jails. There's two ways we can do this. We can do this using the sysrc command, or you can manually edit the etc.rc.conf. So what we're doing here is saying jail enable yes, jail parallel start equals yes, and then jail list. And the jail list is a list of jails that we want automatically started at login. What we need to do next is create a cloned interface here, LO1, so that's, you know, your local host. And what we're doing is we're actually creating an alias here. You can see here init 10.0.0.1.12.24, and what this is going to do is create a load of addresses that we can use with jails to get networking working, as it were. Let me just have some more tea. Okay, so if you have a look at your etc.rc.conf, etc.rc.conf, and you'll see down at the bottom here, jail enabled yes, cloned interface, the alias, parallel start, and the jail list. Okay. So what we need to do next is actually set up the jail directory tree. So what we're going to be doing is we're using ZFS in this example. If you're using UFS, you can, you know, adapt that these commands for your needs. But what we're doing is we're creating some mount points and some data sets. So we're creating zroot jails and setting the mount point to user local jails. So let's have a look here. So if I do zpool list, was it ZFS list? Okay. And where's the jail section? Ah, okay, here we go. So what you will see here is we've got three data sets. We've got zroot jails Linux, and then zroot jails Linux Ubuntu. So we kind of got this divided up nicely, so it's nicely organized. Okay, so what we're doing, first of all, we create this data set, zroot jails, set the mount point to user local jails. So you can see here, OSL, user local jails. And in there we have Linux, and in the Linux directory we've got Ubuntu. So we create the zroot jails, then we create zroot jails Linux and set the mount point to user local jails Linux. Then finally we set up zroot jails Linux Ubuntu and set the mount point to user local jails Linux Ubuntu. And the reason I'm doing it like this is so that I have a separate data set for Linux jails as opposed to FreeBSD jails, and we'll have a separate data set for each jail that we create. So if we create another jail, we can just create another data set for it in, you know, zroot jails Linux. Okay, so that's setting up the data point, the mount points and the ZFS data sets. What we're next going to do is create the etc.jail.conf file if it doesn't exist. So this is what we're going to put in our jail.conf, and you can see down here all of these items link to the example code. So you can see the code here, and then you've got the file which will be included in the repository, so you can just move it into place. So what we've got here is the exec start, stop, and console log. So let's have a look at that. Let's etc.jails.conf. And what you'll see is we just got exec start, stop, and console. And what this will do is this will be a base set that all the jails will actually inherit. So this bit of code is going to be inherited by all the jails. So next what we're going to do is create an etc.jail.conf.d directory, and inside that we're going to have a configuration file for Ubuntu. So create a directory. So you can see here etc jail.conf.d, and inside there we have ubuntu.conf. Okay, so this is the ubuntu.conf configuration for the jail, more T. So what you'll see up here is Ubuntu, curly brackets. You see hostname, host.hostname equals name, and the name is this bit up here. So we have a variable that we can use. Then what we have is the path. So what we're actually doing is specifying the path to the jail. So it's user local jails Linux and then name. So it's getting the name from up here. So that's user local jails Linux Ubuntu. And then what we have down here is some permissions. Allow raw sockets, exec clean. So I think that sort of cleans the environment. Persist, and basically some of these are needed just to get things sort of working. What you'll see down here is this section here, devfs rule set equals 7, and what that does is that actually corresponds to the rule set we created up here. Now you can see up here in devfs.rules, it's called Ubuntu_jail equals 7. However, when we're looking at in the configuration file for the jail, you can see here it's just called devfs rule set equals 7. That might be a bit confusing why the names don't match. It's only the number that needs to match. In the jail config, it's you actually have to specify devfs_rule set equals and then a number. And in the rule set up here, you can call the rule set whatever you want, but it will use that number in the jail so that it will use this rule set. So Ubuntu jail kind of makes more sense describing what it is and what it does, rather than just like rule set 7. So that's why they don't match. It doesn't matter, just as long as the numbers match. So we've got 7 there, and down here we have the devfs rule set 7. Then finally what we have here is the two things, the networking. IP address equals LO 10.10.5.24, okay, and that is the same thing that we actually set up in the rc.conf. See here, we've got the cloned interface, and we've got the IP range we were actually creating. So this is what's needed to actually get the networking working. We've got the devfs rule set, which allows access to the GPU and various other things. Then we have the networking with the LO here. You can see then little pipe, and then the address range we're using. Right, the next thing that we have is the FS tab. So this is the FS tab for the jail. So what you can see here, mount FS tab, user local jails, Linux, Ubuntu, etc. FS tab. You can see up here we have the conf there, and let's have a we'll have a look at the FS tab when we get to it. But what I want to cover here is the PF config, because what you need to do is actually create a PF configuration rule for the jail to allow it access to the network and beyond. So etc pf.conf, and this is the NAT for the jail. So this is the section for the jail, and it's really, really important with PF that there is an order for the rules. You can't just whack this code anywhere. It has to go in a particular section, otherwise it's going to throw an error. So what we have here is NAT on internal interface from LO1, so that's the cloned interface that we created, anti-spoof. So that's basically what gets the NAT working. And as you can see down here, this is a full example of a PF configuration file that I actually use with various other things that you don't need to copy. But I wanted to show you a full PF configuration file to show you where in the configuration file this NAT needs to go. So what you will see here is we're defining the interfaces. We have the table, we have a global policy, we have policy drop, log interface, fingerprint, skip, scrub, and then NAT jail, and then we have the block. So it's absolutely vitally important that you put this in the right section, otherwise it won't work. So you can read the PF manual, but I'm just showing you in a real PF config where that bit of code would go. So it needs to, the NAT section has to come after the scrub but before the block, otherwise it's going to throw an error. So that's the etc pf.conf that we set up. Okay, so the other thing that we're actually going to do is we're actually enabling Linux, and this is for may not be entirely needed, but it's actually used to translate the Linux syscalls into FreeBSD syscalls and stuff like that. And this isn't going to interfere with anything, and you actually need this enabled for a couple of things on my system at least. So what we're going to be doing is we're going to be using sysrt to set Linux enabled to yes in your etc rc.conf. So that's sudo sysrc linux _enabled equals yes, or you can edit your etc rc.conf and manually add in that code. Once you've done that, you start Linux, sudo service linux start, and then what you're going to do is actually edit your fs tab and add in procfs read write. Then let's have a look at the fs tab. Okay, let's etc. So you can see here we got the procfs read write 00. Okay, so that's the fs tab. So what we need to do is actually create an Ubuntu RC script, and this is going to be used with devfs to install Ubuntu inside the jail. Now devfs comes with a set of scripts to install various versions of Ubuntu, and the latest version that was shipped with FreeBSD was actually latest script to install Ubuntu was the jammy script that didn't actually work in my experience. What would happen is it would actually set all the permissions of all the binaries and the libraries to 700 so that only root could run them, which was really lame because basically it means you couldn't use it. So what I did was I modified the scripts to include Luna and Mantic. So what we're going to be doing is using a modified version of the script to actually install Ubuntu Mantic, the latest version of Ubuntu inside of the jail. So what we've got here is the path to the two scripts, Luna and Mantic, in the repository. And basically you just copy them into place. So you can see here, copy this Luna script from the repository into user local shared devfs scripts, and the same for the Mantic one. And you can see here, this is the Mantic and Luna scripts. And basically the only changes I actually had to make was to add Luna and Mantic into this array down here. So once we've got those installed, I'll scroll down past this section. What we're going to need to do next is to create the mount points for Ubuntu. So we're going to create the mount points for the Ubuntu jail. So this is the location that we're actually installing the Ubuntu jail, user local jails Linux Ubuntu, and I'm using the ZSH shell, which is why we can actually use brace expansion here. If you're using another shell, you'd need to create these directories manually if your shell doesn't support brace expansion. So we're creating user local jails, Linux, devfd, shm, home, temp, proc, and sys. So we create all those directories, and what that's going to do is user local jail Linux Ubuntu. That is going to create a lot of these directories. Not all of them. Some of these will actually be created after you've installed Ubuntu, but that's the next step we need to go through. So what we're going to need to do is use devbootstrap with the Mantic script we created, as well as this URL here. So this URL actually points to a repository that has Mantic and Luna in it. So what we're going to do here is run sudo devbootstrap --arch equals AMD64, no check GPG, Mantic, then user local jails, Linux, Ubuntu, that's the location we're installing it. And at the end, what we need to do is have this URL so that it can actually pull down the Mantic version of Ubuntu. Okay, so once that's finished, what I found is when I was trying to set this up, that there was an error with creating a sort of master password, you know, like a root password and stuff. So what we need to do is run cd user local jails, Linux, Ubuntu, etc. So come across here. Okay, so we're in this directory here, and what you'll see is this file here, master password. So what we need to do, and again, we're on FreeBSD. We haven't logged into the jail. We've not booted into the jail yet. We're still on the FreeBSD host. So we've changed into this directory, and then what we're going to do is run this command: sudo cat password sed master password. So there is actually a password file in it, lmnop password. So you can see here, password. What we're doing is we're actually catting that password file and outputting the results into a file called master.password. Once we've done that, and while we're still in this directory on the FreeBSD host, we run sudo pwd _ mkdb -d ./-p master.password. And once we've done this step, we can then go through the next stage of the setup. But this is just an issue that I came across, and this is the bit of code that actually fixes the issue. Right, so the next thing that we're actually going to be doing is creating the Ubuntu jail fs tab. So you can see here we've got the link to the fs tab, we've got the path to the fs tab from on the FreeBSD host. So this is actually showing you the path. That would be the path inside the jail. So this is the path. So basically what you can just do is on the FreeBSD host, just edit that file and put in this code. So what we've got here is devfs, tempfs, the script fs, lin procs fs, lin sysfs, temp, and home. And what you'll see is these are all mounted in like user local jails, Ubuntu dev, proc, home, what have you. So this is the fs tab. Okay, so that's the fs tab there. Right, so the next thing, once we've got the we've made the change to the master password, we've created the fs tab, we've done all that setup, we can actually start the jail. So what we're going to do is we're going to, because at this stage we haven't actually rebooted to get the jail to automatically start. Okay, so what we're going to do is run doas service jail one start Ubuntu. Once you've got this set up, you won't need to do that. It will be sort of automatic. So we run doas service jail one start Ubuntu, and then we can check this jail is running with doas jls. And then what we can finally do is actually enter the jail with doas jexec ubuntu bin bash, and we set up the doas section earlier so that we can run that without a password. So let's come across, copy that, and come across, and let's just put in tmux. So as you can see here, I'm going to run doas jexec ubuntu bin bash, and you can see we're now root. Okay, we'll now go through the Ubuntu setup. I've covered this in the previous video about setting up the ch root, so you can always have a look at that video for a more in-depth step-by-step guide. But since I've already covered that, I'm just going to kind of whiz through this. So we've logged into the jail as root. So what we need to do is actually set the correct time zone inside the jail. So we're inside the jail, and what we need to do is run this command to adjust the time. After we've done that, we're going to install sudo, apt install sudo, because we're root. We don't, we don't need to do anything. So apt install sudo, and what we need to do is actually reconfigure the TZ data, and for some reason you have to use sudo with this. So what you do is run sudo dpkg reconfigure TZ data, and that's going to come up with a screen where you can sort of set the locale, choose your country and set the locale. After we've done that, we're going to fix the apt package manager. So again, we're still root, so we run this command here, and this fixes an issue with the apt package manager. What we're then going to need to do is actually enable some more repositories on Ubuntu, and the way we do that is by editing the sources.list. So this can be user local jails, Linux, Ubuntu, etc. apt sources.list. Inside the jail, it would be etc. apt sources.list. Here's a path, here's the file, and this is what we need to put into it. So let's have a look. I've already set this up. So if we have a look inside here, what you'll see is deb trusted yes. This is needed for the latest versions of Ubuntu, otherwise it's going to throw an error, that authentication or GPG keys or something or other. But what we've got here is main updates and security here. Okay, so that's the etc. apt sources.list. What we then need to do is echo the name server into etc. resolve.conf. So etc. name server 888, which is Google, choose wherever you want, into etc. resolve.conf. So let's have a look. Okay, name server. Once we've done that, we can run apt update and then apt upgrade. All right. We then need to set the locale. So this is the location of the locale in the jail. So what we're going to do is actually add this code to the etc. default locale. So let's have a look. So adjust this code for your locale basically. This is set for GB. Right, so once we've got that, we're going to run locale gen and dpkg reconfigure locales. Right. What we're going to do next is actually install the shell and ZSH. So in my case, I'm using ZSH, as I said, and pulseaudio here. So apt install ZSH and pulseaudio. And I covered this next section fully in the chroot video, but basically what we're going to do is we're going to copy the user and groups from Freebsd to Ubuntu. We can just copy the settings from our user from the Freebsd password file, etc. password to the password file on Ubuntu. Okay, so let's have a look at the etc. password file. So what you can see down here. Okay, you can see here my entry there. So basically what you do is, as I said, I covered this in a previous video, is we just copy the entry from the FreeBSD password file to the password file on Ubuntu, and you can actually edit that file from the FreeBSD host. Now, the one thing that you actually need to do is change the path to the shell. So if I come across here, let's have a look at this. Okay, so you can see here the path. What we're going to be doing is actually copying this whole string from FreeBSD to Ubuntu. But the one thing we need to actually change here is you can see here the path to the ZSH shell on FreeBSD is user local bin ZSH. Which ZSH, see I'm in the jail here, is user bin ZSH, less, etc. password. So what you'll see here is the the password entry, and what you can see here is I've just changed the last bit to bin ZSH instead of user local bin ZSH on FreeBSD. Right. So what I can also do is I haven't logged in as root. I'm still logged in as root, but once I've moved to the next step, I'll show you the IDs match. So the other thing that we're going to do is actually copy the group from etc. group on FreeBSD to etc. group on Ubuntu. So let's etc. group. Okay. Where's my? Okay, you can see down the bottom here. Here's my group. So this is what we're going to be copying from FreeBSD. Let's etc. 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 group. Come on. Okay, and if I come down to the bottom, what you'll see down here is we've got that entry that we've added. Okay, so basically what we've done is we've copied the password and group settings from FreeBSD to Ubuntu. The reason for this is so the IDs match, so you're not going to get any permission errors. So once we've done that, what we're going to do is actually inside the in the jail, what we're going to do is add our user to various groups on Ubuntu, and you need to replace username with your username here. And again, we're doing this as root, so you can see I'm adding it to various things: sudo, plug dev users, video, audio, pulse access, that sort of thing. And then you can either do that using the group command, or you can just edit the group file. So group, and you'll see that I've been added to all these groups here, like sudo, cd-rom, audio, pulse, that sort of thing. So we're getting there. Next step is sudo setup. So as root, what we need to do is run vi sudo to edit the sudo as file, and then add our user to the sudo as file and change username to your username. Okay, vi sudo, and if I scroll down here, what you'll see is under this section, user privilege specification, basically all you need to do is just copy the root line here and change it to your username. Okay, so that's the sudo as file taken care of. what we need to the next thing that we need to do is actually create a password for the user. So we're still root. So what we're going to do is run password and then the username that you've created, and then put in a password. Right. So what we're going to do next is actually, if the home directory doesn't exist, we're going to create it running make dir-p home username, and then chown username, and then username. So you can see here, I've actually created the home directory. This step's only needed if it doesn't exist already. Okay, so next step, couldn't resolve hostname fix. So what you'll get is sometimes when you're running sudo, you'll get an error saying couldn't resolve hostname. So the way you fix that is editing the etc hosts on FreeBSD and adding in 120.0.0 and then the host name. And let's have a look. Etc hosts. So you can see here we've got localhost and then Ubuntu, which is the host name of this jail, and that will fix that error. Okay, finally getting there. So now we've done all that, we can actually switch to our user with su. So we're going to run su dash and then username. So su dash username. And what I want to do now is actually show you the ID. So here I am on FreeBSD. If I run ID, you'll see the UID is 1001, GID is 1001, groups 1001. Switch across to Ubuntu, logged in as my root user. You can see we have the same UID, GID, group. Okay, so that's so we don't get any permission errors. And this is going to be important when we're going to mount the video directory from the host inside the jail, so that we can access stuff from the host in the jail and don't have to copy files in and out. Okay, so as I said, I've covered all this section in the video about installing Davinci Resolve and the CH root, so I've got kind of more. If you want to follow along in that video, you can. Basically what we're doing is we're installing build essential, ffmpeg, and we're actually going to download the Nvidia driver install for the same version of the driver that is installed on the host. How do you find the driver that's on the host? An easy way, you can just use Nvidia SMI. Nvidia SMI. See the driver version here, 5E514602. So you have to download the exact same version that's on the host. So what we actually do is once we've downloaded it, we're actually going to copy that Nvidia run file to user local jails, Linux, Ubuntu, home, and then user. And that's going to be our username. We then, when we're inside the jail, what we do is we run change mod to make it executable, and then run this command here to actually install the Nvidia driver. After we've done that, we install the Nvidia toolkit. And for good measure, we actually blacklist the Nouveau driver in this section here. Update it, init RAM FS. Okay, so what we're then going to do is actually just install some packages for Wayland. So we're going to install WL root stuff here. And the important thing that we need to do is actually create the XDG runtime directory in the jail. So we're going to run sudo mkdir-p var run user, and then this is going to print out our ID. So once we've done that, we actually chown it and change the permission. So if I come across here, lsl var run user 1001, what you'll see is this is the XDG runtime directory, echo XDG runtime dir. You can see it's actually run user 1001, and that's because there's actually a symlink that points from this location to this location. Okay, so that's needed for hardware acceleration and stuff like that. This is where we're actually going to set up the shell config. So this is ZSHRC and ZSHEMV. Okay, so these are some things we need to actually set up. We need to preload this dummy uvm.so file, and that's included in the repository. So we're actually going to copy that file into the jail. These settings here are actually needed for Davinci Resolve. We export the display, export QTA platform as XCB, which is X11, and this is the ZSH EMV code, basically. You can see here we're specifying the XDG runtime directories. What we're also doing is setting our path to include opt-resolved bin, and what that will allow us to do is run Davinci Resolve just by typing resolve instead of the full path to the binary. Okay, and again, I've gone through this in more setup in the chroot video, so I'm just kind of whizzing through this. We install X11. What we need to do is install these two packages, fakeroot and Xwayland, and these are needed for the make resolve deb file, which is used to take the Davinci Resolve installer and convert it into a deb file that we can easily install. So on the Freebsd host, basically you download Davinci Resolve here. Once you've downloaded that, about 2.4 gigs, it may take an hour or so, you copy that into the jail. You download make resolve deb, you copy that into the jail, and what we do is we make sure we switched into the jail and we're switch to our username as we are here. Okay, and what we need to do is install zip. We can then unzip Davinci Resolve, untar the make resolve deb file, and then you run make resolve deb with the Davinci Resolve installer, and that will create a deb file that you can install. It can take about an hour to do, and then you can just run sudo dpkg-i and the path to the deb, and it will install Davinci Resolve. Okay, there's a couple of things we need to do to actually get Davinci Resolve working. There's a couple of fixes that we need to apply. So what we need to do inside the inside the jail rather, is change to cd opt resolve libs. So cd opt resolve libs. And what we need to do is actually rename this lib glib-2.0.so.0 and append back to the file name. Then what we're going to do is actually copy the glib file from the system library into the resolve libs directory. Okay, so you just need to follow these commands, and then finally we install lib blog4cxxx-dev, which is another package that we need to resolve an error. Okay, pulse audio. So this is the pulse audio setup. What we do is we actually have a default pulse audio file here. Okay, so this is going to be for the Freebsd host. And what you can see here is we're including the default system pulse audio file, and we're appending some options to it. So these are settings. What we're going to do is actually load this module called eSound Protocol Unix.so, and what we're going to do is actually use that to create a socket in temp pulseaudio.socket. So what happens is when pulse audio is started on the FreeBSD host, what it's going to do is actually going to create a socket file in temp called pulseaudio.socket. Okay, let me just show you that. So .config pulse default PA. So there you go. That's the code in .config pulse default PA on the FreeBSD host. Okay, so then what we have is on Ubuntu, what we have is a file called client.conf, and that's going to be in user local jails Linux Ubuntu home username.config pulse client.conf. So that's the path on FreeBSD, and the path inside the jail is going to be .conf pulse client.conf. There's the file, so what we can do is just copy that file from the repository into the jail, and this is basically the code here, and this is just a line default server equals temp pulse audio.socket. And what this does is this basically allows the jail to connect to the pulse audio server on the FreeBSD host using that socket in the temp directory that is actually mounted inside the jail. Okay, so getting there. So this is the FreeBSD Resolve desktop entry file. So what we have here is a file called Resolve that we've created, and this is the path to the script in the repository. And basically you just copy this to user local bin on the FreeBSD host, and as you can see here we have two lines of code. We've got pulse audio -- start demonize, and then doas jexec ubuntu user local bin wrapper resolve -u user, and the wrapper resolve script is the thing we're going to be setting up next, and that's what's used to actually launch Davinci Resolve inside the jail. Okay, so the wrapper resolve, this is the path to the script in the repository. We just copy the script to the jail. So we're copying that into user local jails Linux Ubuntu user local bin. Okay, and this is basically the script. So this is the bit that we're interested down here. su username -c optresolve bin resolve. So what this does is this actually will execute your username here. You don't need to change the username. Let me just make sure I've got the user local bin wrapper resolve. Yeah, okay, right. So the way that this works is the first script, the resolve script up here, yeah, this is on the FreeBSD host. You can see we're running this as our user, okay? So we're running this script as our user. You can see here user, and what happens in the script down here, username, we're actually grabbing the username that's passed in to this second script. So this will switch to our user inside the jail. So what this does is it uses doas without needing a password. It enters the jail and it runs this script as our user. This next script then switches to our user. So instead of booting in as root and trying to run Resolve as root, which you don't want to do, it will switch to our user and then execute this command, which will actually open Davinci Resolve. And then finally, what we have down here is the actual desktop entry for FreeBSD. So basically all you need to do is copy this file from the repository into local share applications. Okay, home, local share applications. This is the Davinci Resolve desktop entry. You can see I've modified the path to the icon so that the icon should show up in the application launcher. And you can see on the exec line here, what it's doing is it's launching this Resolve wrapper script on FreeBSD that then runs the script inside of the jail to launch Davinci Resolve. And then finally what we've got is how we actually mount the video directory from the FreeBSD host inside the jail. This is basically to set up FreeBSD so that you can mount directories without needing to enter your admin password. So you can run sudo sysctl devfs.usermount equals 1, or you can edit your sysctl.conf file and add the following options, and that will allow you to mount the video directory from the FreeBSD host inside the jail. Okay, so what we're going to do on the FreeBSD host, we're actually going to create a directory. You can see we're not running this as root, and that's because we've matched the IDs, so we can actually create directories and access files in the home directory inside the jail from the FreeBSD host without any permission errors or having to use sudo or anything like that. So this is basically, you create the directory. There's going to be the mount point inside of the jail. And you can see here what I'm doing is using nullfs to mount the video directory from the FreeBSD host to the video directory inside the jail. And so what that basically means is that you can copy files in and out. So let me just come across to etc fs tab and just grab that code and just mount it. Show you what I mean. Okay, so here we are inside the, if I have a look inside the video directory, you'll see it's empty. So you can see here, these are the directories in the home directory in the jail. As you can see, if I list the video directory, it's empty. Here's the FreeBSD host. If I list the video directory, you can see the contents there. What I'm going to do is just run mount and that path. Okay, so what I've done now is mounted the video directory from the FreeBSD host to the mount point inside the jail we created. So now if I switch back and list the video directory, you'll see we've got the video directory mounted from the host to the jail. And what that allows us to do is import and export footage from Davinci Resolve directly from that directory, as opposed to constantly copying files back and forth to the jail, which would be stupid. So, as I said, what that does is that will allow us to actually access all those files from that directory on the host inside the jail, so that we can actually work with the footage that we've got stored in there. Okay, so that's basically the gist of it. That's a rundown of Davinci Resolve in a FreeBSD jail.